Okay, so we're diving deep into this whole grokking thing and machine learning. It's really got people talking. And you sent over this fascinating research paper, Grokking at the Edge of Linear Separability. I have to admit, I'm pretty curious to unpack this whole aha moment in AI.
Yeah, it's really interesting stuff. It kind of challenges the way we traditionally think about AI learning. Instead of gradual improvement, we see this sudden shift, like from just memorizing to actually understanding.
Right. It's like the AI is struggling, then bam, it just clicks. So, how did the researchers even begin to study something so seemingly random?
Well, they wanted to get to the core mechanics, so they started simple. Instead of complex images, they used random points in a high-dimensional space,
Yeah.
basically training the AI to separate a signal from noise.
Interesting. So, it's like finding a pattern in what seems like total chaos.
Exactly. And get this. They found that this grokking thing, that sudden understanding, it happens most often when the data is almost, but not quite, linearly separable.
Now, remind me what linearly separable means again. It's been a minute.
Oh, right. So it just means you can draw a straight line to divide the data neatly into categories. Think separating marbles. If you can draw a line between the red and blue ones, that's linearly separable data.
Okay, right. So this edge of separability you mentioned, where the data is almost perfectly organized but not quite, that's when grokking is more likely to happen. Why is that?
Well, that's the million-dollar question, isn't it? This finding suggests that grokking is somehow connected to how well the data represents the underlying problem the AI is trying to crack. It seems like the AI needs just the right amount of challenge for that aha moment.
Interesting. So it's not enough to just throw tons of data at the AI. It needs to be pushed just a little to figure things out on its own.
Exactly. And the researchers actually have a term for this. It's called the interpolation threshold. It's like that tipping point where the AI goes from memorizing to generalizing, applying what it's learned to new info.
I see. That makes sense. Can you give me an example of what that might look like?
Sure, imagine 2 points on a line. If they're super close, it's difficult to draw a clear separating line with the origin on one side. This is data that's hard to separate.
Yeah.
But move the points further apart, you get that edge of separability, and suddenly it's obvious. The AI understands, it can generalize.
Ah, that's a great visual. Like going from blurry vision to suddenly seeing everything in sharp focus. So this interpolation threshold is crucial. What else happens at that point, according to the research?
Well, they found that at this threshold, the S infinity, which is like the end result of the AI's learning, changes significantly. It's as though the AI needs to build up this big mental model of the data, and only then, bam, those crucial connections are made.
So the AI is building a mental framework. Fascinating. And the speed at which it does this affects how fast grokking occurs.
That's right. They found this parameter called sigma, which deals with the scale of the data. Increasing it basically highlights the differences between data points, and boom, the AI seems to get it faster.
So it's like turning up the contrast to make the important features pop. Okay, this is all really interesting. But they also looked at how different optimizers, those algorithms that help AI learn, affect this process, right?
Yes. And what's interesting is they found that using an adaptive optimizer, like Adam, can actually speed up grokking. Adam's cool because it adjusts the learning rate for each parameter, kind of like fine-tuning, so the AI can zero in on that critical point of separability much faster.
So we're giving the AI better tools to navigate that data landscape, but all of this is still in this very controlled, simplified model. How does it apply to the messy real-world data we encounter every day?
That's the big question, right? And it's important to remember that this research was done in a specific setting. But the insights? Oh, they could have big implications for how we understand AI learning overall.
It's like a stepping stone to understanding the how and why AI does what it does.
Precisely. By studying these simplified situations, we begin to untangle the incredibly complex web of factors that affect AI learning. And that includes this whole grokking phenomenon.
You're right. This research has given us a lot to chew on. We've covered random points, data separability, the way AI learns. But before we go any further, let's also talk about what this research doesn't tell us. What are some limitations of the findings?
Oh, absolutely. It's key to acknowledge those. This was a controlled environment, a specific type of data and task. We don't know yet how well these findings apply to more complex AI tasks, like natural language processing or image recognition, where data is unstructured and always changing.
Right. We can't just assume these same principles apply universally across all of AI.
Exactly. We need much more research, particularly in other AI domains. It's also good to remember this research is mainly focused on the theoretical limits of grokking. Real-world AI training, well, that's a whole other beast. Things like computational resources and the AI model's architecture can also impact how long grokking takes, or if it even happens at all.
So there are still plenty of unknowns when it comes to grokking, but hey, that's part of what makes it so exciting. This research has given us a peek into how AI might be achieving those aha moments and the crucial role data plays in all of it.
For sure. And it raises more questions about how we can use this knowledge to build AI that's more efficient, more robust, really exciting stuff.
Absolutely. And, there's this one point in the paper that really caught my eye. They call it a provocative thought.
Oh, yes, I remember that. Not every day you see researchers end a paper with such a philosophical question, right?
It really gets you thinking. They ask if we could actually design better AI by intentionally pushing it towards that interpolation threshold, that edge of separability. Could we encourage more of those aha moments?
It's a wild thought, isn't it? It's like we're not just feeding AI data and I'm hoping for the best anymore. We could be engineering these grokking moments, guiding AI to a deeper level of understanding.
So we're not just teachers, we're becoming architects of understanding.
Mm.
But how would we even begin to do that? What kind of tools or techniques could we use?
See, now that's where it gets really exciting. Imagine algorithms that automatically adjust the data or the model's parameters, keeping it constantly balanced at that optimal level of challenge. It's a goldmine for future research.
It really is. This whole conversation about grokking has taken us from random points on a graph to the very heart of AI understanding. It makes you wonder.
What else is out there? What other AI mysteries are waiting to be discovered?
Precisely. This research shows we're just scratching the surface of what AI can do. And frankly, I'm beyond excited to see where this journey of discovery takes us. We'll explore that provocative thought a little further right after this.
It's really like finding that sweet spot when you're teaching someone something new.
Oh, tell me more about that.
Well, think about it. If it's too easy, they get bored, they don't really learn.
Yeah.
Too hard. It's
Uh-huh.
discouraging, right? This research kind of hints at the same thing being true for AI.
That's fascinating. A parallel between how we learn and how AI learns. So how could we actually use this whole grokking thing, this interpolation threshold, to design better AI? The researchers called it a provocative thought, and I have to agree.
Right. It really makes you think, what if we could create AI that doesn't just passively absorb data, but actually seeks out that sweet spot of challenge?
Wow, so instead of just throwing data at the AI, we'd be guiding it to a deeper understanding.
Exactly.
Yeah.
Now, the big question is, how do we get there? Could we create algorithms that are constantly adjusting, making sure the AI is always right at that edge?
So the AI would be learning how to learn best, almost like it's developing self-awareness about its own process.
Right. That's a really interesting way to put it. It's a whole new area for exploration. But this research gives us a place to start.
It definitely highlights how intertwined the data, the learning process, and this grokking phenomenon really are.
Absolutely. And, it really makes you appreciate how much we don't know about AI and how it learns. It's humbling in a way.
It is. But as we uncover more, it's incredible to think about the implications, right? It's not just about smart machines. This idea of a sweet spot for learning that resonates with us as humans too.
100%. We've all had those aha moments when something finally clicks. After we've wrestled with it, struggled maybe, who knows? There might be more parallels between human learning and AI learning than we realize.
There very well could be. This deep dive has given us so much to consider. We started with grokking, and now we're talking about the very nature of learning itself.
And to think, it all began with some random points on a graph.
Right. It just goes to show that even the most abstract research can lead to these incredible insights. Insights that could totally change how we understand AI.
And its potential.
Exactly. This feels like just the beginning of a much larger conversation about grokking and what it could unlock. It really makes you think, what other AI secrets are out there just waiting to be uncovered?
It's funny. Each new discovery seems to bring up even more questions than answers.
It's true, but I think that sense of mystery, that constant exploration, it's part of what makes AI so captivating, wouldn't you say?
Absolutely. It never gets old.
Well, this deep dive into grokking has certainly been fascinating. We've covered so much ground, from the nuts and bolts of how this phenomenon works to the bigger picture of AI learning and even, maybe, understanding how it learns.
And just imagine the potential applications, right? If we could actually harness this grokking thing, what could we achieve? AI that solves problems more efficiently, makes better predictions, even designs solutions we haven't thought of.
It's incredible to think about, really. But for now, I think it's time to wrap up this deep dive. We went from random points on a graph all the way to the very heart of AI understanding. And it all started with this research on Grokking.
It's been a pleasure, as always.
The pleasure was all mine. And to everyone listening, thank you so much for joining us on this deep dive. We hope you've enjoyed exploring the fascinating world of AI and this whole idea of grokking as much as we have. And until next time, keep those minds curious and keep asking those questions.